Similarly, substitute x is equal to 0. We get y is equal to 0 cube minus 4 into 0. This is equal to 0 minus 0. This implies y is equal to 0. Substitute x is equal to 1. We get y is equal to 1 in cube minus 4 into 1. This is equal to 1 minus 4. This implies y is equal to minus 3. Substitute x is equal to 2. We get y is equal to 2 cube minus 4 into 2. This is equal to 8 minus 8. This implies y is equal to 0. Now let's plot the above points or coordinate on a graph. Locating the points of the table on a graph paper, and drawing the graph, we see that the graph of y is equal to x cube minus 4x actually looks like this. Here arrows indicates that the curve cuts the x-axis at 3 points, that is, at x is equal to minus 2, 0, and 2. So, minus 2, 0, and 2 are the only points of the x-coordinates where the graph of y is equal to x cube minus 4x intersects the x-axis. Since the curve meets the x-axis in only these 3 points, their x-coordinates are the only zeros of the polynomial. Now let's see some examples to find the zeros of the given polynomials, or given graphs of the polynomials. Example 1. The graph of y is equal to p of x as shown in below. For some polynomial p of x, find the number of zeros of p of x. Solution. Here, by observing the above graph, we can say that the curve meets the x-axis at 4 points as shown in graph using arrows. Here arrows indicate that the number of zeros is 4 as the curve intersects the x-axis at 4 points. So, here the x-coordinates are the only zeros of the polynomial. Let us take one more example. The graph of y is equal to p of x, as shown in below. For some polynomial p of x, find the number of zeros of p of x. Here, by observing the above graph, we can say that the curve meets the x-axis at 1 point as shown in graph using arrow. And their x-coordinates are the only zeros of the polynomial. Therefore, number of zeros is 1 as the graphs intersect the x-axis at 1 point.